Some indeterminate forms are not expressed in a way that makes applying L'Hopital's rule easy. So 1 to the infinity, 0 to the 0, infinity to the 0 all involve exponents. They can evaluate to any number of values, but we can't evaluate them directly without changing them a little bit. And the way we're going to do that is we're going to take the logs. We're going to use logarithms because those allow us to get exponents down, and once they're down, we can turn the expressions into forms that allow us to use L'Hopital's rule. So for instance, this limit here, if you plug in 0, you end up getting 1 plus 0, which is 1, and 1 over 0 is infinity. So this is a 1 to the infinity form, right? So again, you would think that, oh, that's just 1, but it really does matter. I mean, the subtle distinction between something being 1 and something approaching 1 really makes the entire difference here. So this may not be 1. It probably isn't, in fact. So, but here's how we're going to do this. Let's just say this whole limit is called a. The strategy we're going to use is we're going to note that, okay, well, let's say I take the ln of something like a, and I actually get an answer. Now again, our goal is to find out what a is. A is the limit. Well, based on the definition of log, natural log, that means that e to the l is equal to a, which is what we want, right? So our strategy is going to be to take the natural log of the limit. We're going to take the natural log of the limit, see if that can be evaluated, and if it can, we'll just raise e to that number to get a. So that's our strategy. Okay, so the natural log of this limit now, nice property of limits allows, which it probably didn't, I don't know if it showed up in the list. It allows logs to move inside the limit. So this is the same as the limit as x goes to 0 of ln of 1 plus x to the 1 over x. So again, the limit and the ln just switched places. Now here's where I use that very nice property, which allows me to take this and move it down. So this is equal to the limit as x goes to 0 of 1 over x times ln of 1 plus x, which I think would be better if it was written as the limit as x goes to 0 of ln of 1 plus x divided by x. And now you can see we have a 0 over 0 form. So we can use L'Hopital's rule. So the derivative of the numerator is 1 over 1 plus x. The derivative of the denominator is 1. And now when I plug in 0, I get 1 over 1 plus 1 divided by 1, which is 1. Alright, so remember that's not our answer, because we just evaluated the natural log of what we want. So we need to raise e to that answer. So we know that ln of a equal to 1. So that must mean that our actual answer is e to the 1. Alright, so again, we take the natural log, we get a value, and then we just raise e to that number to undo it. Let's do another one. Let's do the limit as x goes to 0 of x to the x. So again, you plug in 0, you get a 0 to the 0 form. which is indeterminate. So what we're going to do is we're going to take the natural log of this limit to get that exponent x down. That equals the limit of the natural log of the expression inside. So that equals the limit as x goes to 0 of x times ln of x, right, again, because that can move down. So now I've got a 0 times infinity, technically negative infinity, because as x approaches 0 of from the right of ln of x, we go to negative infinity. But in any case, we can't use L'Hopital's rule until we write this as a fraction. So we're going to write this as the limit as x goes to 0 of ln of x divided by 1 over x. And now I've got an infinity over infinity form. Again, it doesn't matter that the numerator is technically negative infinity because the natural log approaches as negative infinity as x goes to 0 from the right. It tends not to matter. So in any case, we can use L'Hopital's rule. The derivative of the top is 1 over x. The derivative of the bottom is negative 1 over x squared. Now before you use L'Hopital's rule again, because if you notice this is now again infinity over infinity, do some cleaning up using algebra and you'll find you probably don't need to use it again. So this is the same as negative x squared over x, which is just, after canceling out, so it's just going to be 0. So that means that our actual answer is e to the 0. So the limit itself is going to be e to the 0, which is 1. Alright, so there's a couple of examples on how to use L'Hopital's rule when you're dealing with indeterminate forms that involve exponents. Again, the general strategy, which I'll circle here, is to take the natural log of the limit, get an answer, and then raise e to that answer. Let's finish with an example that looks like one of the ones we did before. It's the limit as x goes to 0 from the right of 1 plus 1 over x to the x. And actually what I'll do is I'm going to change this 1 here. I'm going to change that 1 to just a constant because you're going to see that that's going to allow, we're going to solve something more general than this. So let's just make that like an a. So again, if you plug in 0, you're going to get 1 plus 1 over 0, which is infinity to the 0. So this is an infinity to the 0 type. Alright, so again, we're going to take the natural log. Which of course equals the limit of the natural log. We're going to move this down so that we get the limit as x goes to 0 from the right of x times ln of 1 plus a over x. And this is a 0 times infinity form, so I'm going to have to change it. So I'm going to write it as ln of 1 plus a over x divided by 1 over x. So the denominator is infinity and the top is infinity now. And so I can use L'Hopital's rule. So this ends up being the limit as x goes to 0 from the right of 1 over 1 plus a over x, and then don't forget to times by the derivative of the inside, which is negative a over x squared divided by the denominator, which is negative 1 over x squared. And again, before you use L'Hopital's rule again, note that the numerator and the denominator will cancel out to result in this. And we can see here now that we are once again, well, in this case we're dealing with negative a over 1 plus a divided by 0, which is a over infinity, which is just 0. So this ends up being, so the value is 0. So our actual answer is going to be e to the 0. Which is 1. So you can see that a, whatever that a is, whether it's a 1 or not, it doesn't matter. This is still, as you approach 0 from the right, you're still going to approach 1. Alright, so there's all the different cases of L'Hopital's rule, and hopefully at this point you just can get some practice so that you know how to handle all the various types.